Welcome to ProgrammingKT. Today in this tutorial I am trying to explaining about set interface and its implemented classes. In last video I already explained about introduction to collections, definition about collection, why generics are introduced and what is the main purpose of generics. So and moreover that list interface and its implemented classes like array list, linked list, vector, stack, and what is the difference between array list and linked list, when to use array list, when to use linked list. So I explained all these details with some examples. If you did not watch that video, watch that video, then start watching this video like set interface and its implemented classes. So set is a interface and its implemented classes are HashSet is a class, LinkedHashSet also class, TreeSet also class. So navigable set and sorted set are the interfaces. So anyway, root interface is iterable for set also. Set parent is collection parent is iterable. So whatever the methods available under iterable and collection by default available inside this hash set and linked hash set, tree set also. Now let me try to explain about high level difference between set and list. Then I will explain about set implemented classes. So here when you are talking about list versus set, so the main difference is here list duplicates allowed. So here duplicates not allowed. That is the first difference. And moreover that insertion order allows. Insertion order not allowed. That is the main difference. You need to understand list versus set. So and moreover that null values. Here n number of null values. Even null also duplicate values you can enter. But in set only has set null value allows. But in linked only one null value has set and linked has set. But in tree set null value is not allowed. You will get null pointer exception when you are trying to add. So this is the high level difference between list and set. Now let me try to explain about major differences between remaining classes like has set, HashSet. Next one is LinkedHashSet. LinkedHashSet. Next one is TreeSet. These are the three classes, right? Set implemented classes. So, so first difference, you need to understand about internal data structure about all these three implemented classes. So, HashSet internal data structure is hash table. So that's why we can't predict the order, insertion order, we can't predict for HashSet. So internal data structure for linked HashSet is linked list plus hash table. Linked list plus hash table. And internal data structure for tree set is red block tree. So red block tree is nothing but just kind of balanced tree only. So these are the internal data structure for all set implemented classes. So insertion order is not allowed for hash set. Why? Because hash table depending on that hash function it will store the values. In linked hash set, because of the linked list it will preserve the order inside that hash table. And moreover that tree set, so because of the tree data structure it will maintain the order in the form of ascending order by default. Why? Because tree set implements comparable. I will show you the documentation when I'm explaining about tree set. So if you are trying to insert the elements like 9, 8, 10, 7, 12, these are the elements we are trying to insert in tree set. So first element is 9 like this, then next element is 8. All smaller elements of root it will go to left side, so 8 is smaller, go here. And next element is 10. 10 is greater than 9, go to right side. All greater element will go to right side, smaller element will move to left side. Next one is 7, go to left side. 8, 8 is less than 7, false, right? It will go to again left side. Smaller elements always. Now in this case 8 is the root, go to left side. Now 12, 12 is greater than 9, go right side. 12 is greater than 12, go right side, like this. Now you can print the element, this tree set it will print the result like 7, 8, 9, 10, 12. So by default we got the ascending order, right? So that is the internal data structure of TreeSet. Because of this we will get the ascending order result. Now let me try to explain all these remaining differences. I already created some points about all these three classes: HashSet, LinkedHashSet, TreeSet. So now I am trying to explain about all set implemented classes like HashSet, LinkedHashSet, TreeSet. So I already created one package called set. Under that I created three classes. Let me try to open all three. Then I will explain side by side each one. So HashSet. Let me start with HashSet. So HashSet underlying data structure is hash table, and moreover that linked hash set underlying data structure is linked list plus hash table. For tree set underlying data structure is red block tree. So because of this red block tree, red block tree is nothing but just kind of like a balanced tree. That's why we will get the elements in ascending order. Next next difference is duplicates not allowed. If you are trying to add duplicates, you won't get any compilation error, but it will override last element. So in linked hash set also duplicates not allowed. In tree set, duplicates are not allowed. In anyway, set means duplicates are not allowed. That is the one point. Next one is ordering. So we can't predict the order because of that hash function. It may be for each run it will vary. Next one is linked list ordering, maintains the order because of that linked list. Next one is ordering for elements sorting in their natural sorting order in tree set. Why? Because it implement data structure is tree, right? That's why red block tree. Like this, null values also here only single value, and linked has set allows single value. Tree set won't allow null value. You will get null pointer exception. Next one is performance. So constant time performance. Why? Because of that hash function. So it will straightforward big O of one time complexity for accessing all basic operations like adding, removing content to check that size, the element contains or not. For all that are basic operations, we will get time complexity is big O of n. Why? Because internal data structure is hash table, right? That's why. And moreover that thread safe performance for here linked list also somewhat high here when compared to HashSet. Why? Because it maintains internally linked list, right? So if it is linked list, there may be chance of sequential access. You can access the nth node. You need to move from start to end, right? Node by node, node by node. That's why somewhat higher. And moreover, that performance here big of log and time complexity. Why? Because internal data structure is tree. Such a performance is very fast comparing with the remaining two. Why? Because these tree, right? If the elements are in already sorting order, it will go to quick, right? For the element exist or not to get the access for a specific element very fast comparing with remaining two. And next one is when to use. So if you are thinking about, if you don't allow duplicate elements and if you are doesn't consider about insertion order, then go for HashSet. If you want to think about, I don't want duplicates and I want insertion order, go for linked list. So I don't want duplicates but I want some insertion order, by default ascending order, go for TreeSet. If you want to descending order also, you can customize on your own depending on your requirement. That is the when to use HashSet, when to use linked list, linked HashSet, when to use TreeSet. Next one is iterating. So iteration is not guaranteed. We can't predict the elements, same elements again in next time. It may be order may be vary. So here remains the same, right? Nearly identical to HashSet. Accessing the element remains the same comparing to linked list also almost the same to hash set only. So iteration is guaranteed, maybe vary one run to another run. So identical means it will maintain the order, not nearly somewhat this point I need to adjust. So instead of nearly identical to hash set, in hash set order we can't predict, right? But in linked hash set we can predict the order. So this point we need to somewhat adjust. Next one is iterating. Iteration R is guaranteed. Not guaranteed means maybe one run to another run. So this is also when I all these points I am copying from I created on one, then I copied remaining linked list and reset. Some points I maybe because of some points I missed here updating. Here also identical to set, right? These two are I need to update. I mean thread safe, it is not thread safe, contains constant time and complexity. So with point, right now we are discussing about iterating, right, nearly identical to HashSet. This point is, so follows the insertion order, follows insertion order. And next one is iterating for eighth point. So insertion order is by default ascending order. So next point is, so next point is, that is the iterating. Means we can't predict, we can predict by default ascending order. Next, time complexity. So big O of 1, why? Because it uses internally hash table, and here somewhat high comparing with that almost same, but anyway it uses internally linked list, right? Because of the sequential access, it may be somewhat high. Not big O of 1, we can say, but if the linked list is too long, in that case it may be take more than one also. And next one here, log n time complexity. Why? Because the elements are in already sorting order, that's why time complexity is less comparing with previous. Performance tip, generally faster than TreeSet due to constant time performance. Accessing and adding, I mean, there is no need to check, right? Directly you can apply that key to specific hash function, that hash function, depending on that hash code, it will insert the specific position, that's why it is fast. And next one here, performance tip, generally performance due to faster than TreeSet due to the constant time complexity. In TreeSet, we need to, at the time of adding, it will go to, right, if the element is smaller, always, and tree nodes it will check, right, greater than smaller, small greater than smaller than greater than, so like this it will go to and it will insert. That's why it will take some time in TreeSet. In LinkedHashSet, not like that, it will straight go, I mean straight forward. Next one is when to use. I already explained. If your requirement is duplicates not allowed, insertion order is not required, then go for HashSet. If you want duplicates and insertion order is required, go for linked HashSet. If you want default sorting order without duplicates, then go for TreeSet. Anyway, last one, iteration, I think this is the duplicate point. Anyway, we can ignore last one. Anyway, the we already discussed about at point 8. So same iteration, ascending order elements. I think the point 8 is we can remove, we can consider line number, I mean 12. Next, let me try to explain about one by one some questions here. I mean declared, I mean like how to create. This is simple, very straightforward, almost similar to that list also. I mean array list, linked list, how we can create. Here also we can follow same. So but class names and interface names will vary. So set we need to use, set is also from java.util. So here I am trying to take integer, new hash set. Now this is the creating. If you want to default initial capacity, and next one is, let me try to, this is the second question. So hash set 2, I am trying to make different variable name. So if you want your own initial capacity, you can override like this. Previously default capacity will be, let me try to open here hash set, I think 10 or 16, I think default initial capacity here 16. If you can see here, this is the documentation, right? So and it is load factor. So when the, I mean 75% it reaches, it will create new hash set. So that is a load factor is nothing but, so if it is 16, right, so 75% of the 16 you reached the element, I mean set dot add, if you can make 75%, beyond that 75% it will create new hash set. So then old hasset will be copied to new hasset, then old hasset will be removed. So that is default initial capacity is 16, but if you want to override, you can override the 20 or 26 depending on your interest, you can override that default initial capacity. Next one is how to add elements, like set dot add. You can add like this. So if you want to add more than one also, we can add set dot add all, then set dot off. We have some JDK 9 factory methods, right? like this. So if I can print the output here, so order we can't predict. Let me try to print the set. So first I added 12 by I got, but I got 2 here, right? And moreover that 9 I added at last, but I got before, I mean last second. So that is the behavior of hash set by, because we can't predict the order. Next one is how to check the element exists in hash set or not. So for that, set dot contains, if I can pass 9, it will return, or else I can wrap that with a sort statement only. So if that element exists, we will get true, otherwise we will get false. Let me try to check. So I got true. Why? Because 9 exists. If I can pass 99, so that element is does not exist. This is about contain. Almost contains is there and list also same, right? So here also contains only. How to remove element, and moreover that one important point you need to remember. So we can't get the element by using get method. Get method is not available in set. That is the one important point. So you may confuse directly. Anyway, set is, I mean, parent of collection. Some methods will be available by default available in these also, right? So anyway, I think set in set we don't have get, but this is the one important point. So if I can apply get, there is no get, we will get compilation error. But in multiple choice questions or interview round, this is the one important point you need to remember. There is no get method in set, and its implemented classes also. We can't get, why? Because we can't predict the index, right? So this is the hash table. Internal data structure is hash table. We can't get the index of that hash table. So that's why get method is not available in set. Next one is how to remove element from hash set. So by using set dot remove, corresponding object you need to pass, then it will be remove. Now before that I need to print one s out statement before and after. So s out of set before removing, after removing. So now, so before 7 will be there, after 7 won't be there. This is about removing. How to get the size, I mean set dot size, to get the size of a hash set. Size is 4. How to clear the hash set? So in list we can use method called clear, right? But here somewhat different. Let me show you that. Set dot, so here also I think remove all will be there, but I think that is there in TreeSet. Let me try to explain out when I'm explaining about TreeSet. So here also we have clear. Once it is clear, now it is all elements will be removed. Now if we can check the size, or else anyway, if it is empty, I mean we will get size along with size is 0 and is empty true. How to check the set is empty or not? By using is empty. So size is 0, is empty true. Now how to remove all elements from the hash set? So by using how to clear hash set, how to remove all elements from hash set, both are same, right? How to clear hash set, let me try to check that. So remove all, yeah, remove all also method. One method will be there, but collection of elements you can remove. If you can observe this method, I mean overloaded method, collection and collection, both methods are there. So what is the difference between first remove all, second remove all? So remove all expecting collection type of C. Remove retain, this is not remove all, this is retain all. So anyway only one method. So remove all, that is expecting collection. If you want to remove collection of elements, use this method. So if you want to remove all elements, I think specific element, if you want to remove collection of specific element, in that case go for remove all. If you want to remove everything from set, go for clear. So that is about some important point about. Let me try to, instead of comment out this one, so I want to remove all. So collection of means will set of, I am trying to remove 6 and 7. 6, anyway 7 I already removed. 6 2 9. So I need to wrap this inside that set of factor method only. Now if I can print that set, so what is the result? Let me try to print that. So previously, let me try to print the set previously how it is, after how it is this. I mean after removing collection of element. So previously 2, 6, 9, 12. After applying removal with collection of elements, only 12. Now let me try to explain about next one, that is hash set. I mean hash set example for that I already created, right? So here let me try to finish these all these questions like one by one. So how to create linked hash set? So for that also we can use set interface, then its implemented classes. Here I am trying to take string. Next one is set new linked hash set. Here we can predict the order. Let me show you that linked hash set. If I can add set dot add, and more than one also you can add at a time. So set of by using set of, I think the method name is add all with collection type parameter. So set dot, not only set, I think we can pass list also, list dot of. So here I can pass Kotlin Groovy. Now let me try to print it. I think we can, I mean linked has it follows insertion order, right? Let me try to print that set reference. So I got the order Java Go Kotlin Groovy. Irrespective to number of runs, I got the same order. Why? Because of this linked list. The order is, I mean insertion order is preserved. Not only I can add one more. So I got the insertion order. So this is the important point. I mean difference between HashSet and linked HashSet. So HashSet does not allow order, and linked HashSet allowed the order. So if I can add duplicate elements, let me try to, what's happening. So I did not get any compilation error. Here also if I can add after that, I can add duplicate name is Groovy. So I won't get any compilation error, but here I did not see any duplicates, right? So last one will be override into previous one. So that is the important point. So you won't get any compilation error, but override and is happens. Next one is hide, how to create linked asset with default, I mean override that initial capacity. So previously you saw that initial capacity is 16, right? But anyway linked asset also, asset also initial capacity is 16, linked asset also initial capacity is 16. So threshold factor is nothing but I already explained. So when you reach the 75% of the hash set, I mean elements when you are trying to add, then it will create new hash set. In linked hash set also it will create new linked hash set. So if you are trying to override the default initial capacity, yes you can, like this. So hash set new linked hash set, if I can rename that variable name like this, depending on your requirement you can use. How to add elements into linked hash set, here we are already doing that, right? So let me try to set. So like this we can add, how to add elements here. Next one is how to check if the element exists or not, contains. Set dot contains, in pass, it is contains, I mean the element exists returns true, otherwise returns false. Remove the element from the linked hash set. So by using set dot remove with corresponding object name. So it will be the method return type is boolean. If the element is there, it will remove, it will return true, otherwise it will return false. Get the size by using size method, set dot size, and clear the linked hash set dot clear. Linked list is set dot is empty or not by using is empty method. And the next one is remove all, I mean specific, I think. So previously also I explained here, right? So if you want to remove specific, I mean collection of elements, in that case remove all. Let me show you the documentation about linked hash set remove also. So here if we can observe remove all, so it is expecting collection parameter type. So remove all, if I can pass set of, I want to remove. So it is capital S. So we can remove depending on your use case. Remove Java comma Go, like this you can apply. So these are the different methods that exist inside. Not only these methods, I explained basics, how to create linked hash set, how to override default initial capacity, how to add, how to get, how to clear, how to check is empty or not, how to check size, how to remove collection of elements. Not only this, number of other methods also there. So if you want, all these are not thread safe, right? Either it may be hash set, linked hash set, reset, all these are not thread safe. If you want to get thread safe collection, in that case you will use one of the utility class collections. Anyway, this class I did not explain, but let me show you. Collections dot synchronized set, synchronized list, synchronized map. We have these three utility methods present inside collections class. If you want to set, pass that set as a parameter to that synchronized set method, then it will return thread safe collection, I mean thread safe set. So by default all these are not thread safe, right? If you want thread safe, use this method synchronized set. This is also one important interview question. By using collections dot synchronized set, we will get synchronized set. So these kind of number of methods will be there. Check the documentation about linked hash set. If you can press Ctrl O, so get first, get last, remove first, remove last, reversed, split iterator, I mean anyway these are the constructors. So that is about linked hash set. Next one is TreeSet. So TreeSet is by default it will follow ascending order. By because internal data structure is balanced tree. So let me try to create the data structure. So here I did not add null values, right? If here I can add null value, let me show you the documentation, I mean how I will add null. Set dot add null. So if I can add n number of null values, I will get only one null value. Why? Because anyway this is not allowing duplicates, right? For null values also not allowed duplicate, only one null value. So here if I can print, so this is the result, right? Set dot, where is the first print statement? I think here is the first one and here is the second one. I added three times null, but I got only one null. And here also if I can add, let me try to print here. Set dot add null. So I can add more than one also. So I got only one null. It will move to end. Anyway, I added last time, right? You can, if I can add min middle. So I got only one null. I mean first null. It is here. It is only last one is overriding. So only one null value is allowed. Either it may be hash set or linked hash set. But if we can add TreeSet, it will throw null pointer exception. Let me show you that. So for set also interface, I am trying to make parent class is interface, parent interface, parent class reference. I mean interface reference. I am trying to consider here character. So character set new TreeSet. Parent reference child object possible. That's why In real time also they will follow same order. Set interface implemented, I mean object will be class. Now if I can add set dot add of, even zigzag order also you will get ascending order. Let me show you that. So if I can add z, next one is, so here also by using add all method, let me show you that. Set dot add all, I mean collection of set dot of, I am trying to add more than one value at a time. So trying to pass b. Now let me try to print the result. We will get all are in ascending order. So set, I think it will print, yeah, ascending order. So b c d k z, I mean I ordered zigzag order, right? But I got all ascending order because of that tree set. So if I can add null value, so anyway factor methods does not allow null, so we can add here. So I got null pointer exception. Why? Because null is not allowed inside TreeSet, but in linked HashSet, I mean HashSet, it will allow null. That is the one important point. I mean difference between HashSet, linked HashSet, TreeSet. So null is not allowed. How to create? I mean with the default initial capacity. Let me try to check with TreeSet also. What is the default initial capacity for TreeSet? So there is no initial capacity, right? Why? Like in last video in list classes, I mean list implemented classes, for linked list we don't have default initial capacity, right? Not applicable. Like in set also, linked has set also, default initial capacity is, I mean in tree set default initial capacity is not applicable. Why? Because depending on the nodes it will, I mean by default it will move to left and right depending on that order, I mean ascending order. Either it may be ascending order or descending order. If you can observe here, it is navigable set. Parent is the navigable set. Go to navigable set is the sorted set. Sorted set is the set. All this is the collection hierarchy. Sequenced set both extends, I mean both are the interfaces only. Set parent is collection, collection parent is iterable, iterable is the root. So that is the one point you need to remember. Collections hierarchy for set also, root is iterable only. So default initial capacity is not required. Let me try to, I think it is not recommended, but let me try to check. So here we are getting compilation error, right? That's why we can check that, it will be, our doubt will be cleared. Now there is no default cap, we can't override. Why? Because there is no constructor for integer type of constructor in. For this point we can say answer no, there is no default, we can't override, I mean there is no integer type of constructor in TreeSet. Next one is how to add elements by using add or by using add all. Next one is how to check the element exists or not. I think by using set dot contains only, here also contains. So specific character if we can pass, if that exists it will return true, otherwise you will get false. Next one, how to remove elements from tree set. So here set dot remove by using, I mean some method, right? Whatever it may be, a remove method by any one of the character. Here in this case, I want to remove t, like this. You can remove. How to get the size by using size. Set dot size. In size is the method that exists inside set. Next one is how to clear tree set. Set dot clear. How to check the tree set is empty or not. Set dot is empty. How to remove all elements, I mean specific group of elements. Set dot remove all collection type. So you can pass like set of specific group of elements. If you want to remove, you can remove it, something like this. So these are the some important method exist inside. Even this one also synchronized tree set if you want, collections dot synchronized set. So if you want that, collections dot, so synchronized set, we can pass set. Now synchronized set I got for this tree set. So like this you will get thread safe set also. So this is the major difference between all these set implemented classes. So HashSet, LinkedHashSet, TreeSet. So I explained one by one by comparing HashSet versus LinkedHashSet versus TreeSet. So I hope you got some clarity on set interface and its implemented classes. So if you like the content, hit on like button and subscribe Programming KT. Thanks for watching.